Hello Year 12 and welcome to the first video here for our sixth topic. We are looking at the sine and cosine rule here, which we use to investigate properties of non-right angle triangles. Previously, you've done work with trigonometry, with right angle triangles, sine, cos and tan, right? There are some warm-up questions here that aren't asking you to do that right angle trigonometry, just some very straightforward algebra and evaluating some things using your calculator. Rightio. Now, this first video we're going to look at a review of right-angled trigonometry. You need to remember this sine, cos and tan stuff to be able to identify the sides of a right-angle triangle relative to this angle here. So in this first question, in the first example, we have, I have an angle. Opposite that angle is D, which we're trying to find, and I have the hypotenuse, so opposite hypotenuse is sine. So I'm going to say that the sine of 45 degrees 28 minutes is equal to the opposite, D, over the hypotenuse 6.8. Right, a little bit of algebra, we rearrange that and I say that D equals 6.8 times the sine of 45, 28. And then the calculator needs to come out. Now make sure you've got that little D up the top there. If you're using a different calculator, make sure you're in degrees, not in radians or grads. Right? It's very important. You'll get a completely different answer if you do if you're in the wrong setting there. So you should have the little D there. The best way to ensure that happens is to do your reset. Second function 9, 3 equals AC that we did so many times when we were dealing with our data. So 6.8, I'll put it times, sine of 45 degrees 28 minutes, right? Don't forget to put that second, to hit the DMS button a second time there, and equals, right, and we get 4.87. 4.87. It doesn't ask how many decimal places or significant figures to provide there, so 4.87 is fine. We don't put the meters on because it's D meters. Right, because we've got the meters there, I don't need to put it here. But I am going to say that's to 3 significant figures. Rightio. Now the second one here, again we have a right angle triangle. Here's my angle. I've got the opposite and the adjacent. So opposite and adjacent in a right angle triangle is tan. Okay, so I'm going to say that the tan of 24 degrees 47 minutes is equal to 13 over K. Now, our algebra is slightly different this time, and this tells me that K, right, I'm going to multiply both sides by K and then divide both sides by 10, 24, 47, and that leaves me with this expression K equals 13 over the tan of 24, 47. Oops, like that. Back to the calculator. Here we go, clear that away, and 13 divided by, or over, the tan of 24, 47 equals 28.2, let's say 28.2. So I don't need to say meters because we've got the meters here, but I will say to 3 significant figures again. Rightio. Now, a certain amount of common sense can be helpful when checking these answers. You know that the hypotenuse has to be the longest side. So having a look here, D, 4.87, is somewhat less than the hypotenuse. That's fine. Over here, looking at that fairly small angle of 24 here, 13, K will need to be longer than 13, and indeed it is. Right, that's fine. That passes our common sense test. Now, for our third question here, I have the opposite and adjacent again. What I don't have is the angle. So opposite and adjacent is again tan, but this time I'm going to say that tan theta equals 9 on 10, and theta is the inverse tan of 9 over 10. Right, well, I'm running out of space a little bit here. Therefore, theta equals, thank you calculator, here we go, clear, inverse tan, second function tan, right, of, you can go 9 over 10 if you want, like that, equals 41.98, or if we want in degrees, minutes, seconds, 41.59. I think it's probably okay to say that's pretty close to 42 degrees. I'm going to say nearest degree. Rightio. And that's our review of right angle trigonometry. That's straightforward enough. We're also going to have a look here at angles of elevation and depression. An angle of elevation is measured from the horizontal looking up. Depression from the horizontal looking down. Here you can see this little diagram. This person is looking up to a balloon floating in the sky. I have an angle of elevation. Here we are standing on top of a cliff or something, looking at a goose by the looks of things. I have an angle of depression looking down. These are very typically tan questions, but not always. So here we go. I've got one more example before we finish this video. I have a kite with a 30-metre long string that's anchored to the ground. I've got an angle of elevation, 34.20, and I want to know how high above the ground is the kite. What's really important with these questions, if you don't have a diagram, is you must have one. Right, so a good diagram, not too small. So here's my ground. It's reasonably horizontal. Right, now to draw it vaguely to scale helps with our common sense at the end. So I know that I need an angle something like this. Rightio? I'm going to put my little kite on the end here just because that'll be nice. Right, there's my kite. This is my 34.20 in there. Now, your diagram needs to be big enough to label these things accurately. I know that this is 30 metres, and this H is what I want to find. Okay? Check that out. That's what your diagram needs to look like. It needs to be at least that big. Okay? A good big diagram and vaguely to scale. Rightio. So, I can see here I've got an opposite and a hypotenuse, so we're back to sine again. Here's me saying it's always tan, not always tan. So, the sine of 34 degrees 20 minutes is equal to the opposite, h, over the hypotenuse, 30. Therefore, h is 30 sine 34.20, and that's equal to, thank you calculator here again, 30 sine 34.20 equals, let's say, 16.9 meters above the ground. That should do. Rightio. That's our review of right angle trigonometry for exercise 801. Check them out. If you've got any questions, of course, let me know.